Yeah, we will talk about what the Swift. So a bit of weird code will be shown, a bit of weirder explanations will be provided, and then we'll take it from there. So yeah, as I said, this will probably start like this, feeling totally confused, but hopefully by the end, we will have some understanding, meaning, and reason. And we have three things today. We'll talk a little bit about NS object. Anyone working with Objective-C still? Whew, I'm not alone. Thank you, guys. Anyone wrote a line of Objective-C in last month? Yes, cool. Then a little bit about optionals and a little bit about setting properties, which is basically very, very normal things we do every day. But we'll do some twisting and turning, some hand waving. We'll break those things, and then we'll build them back up again. And to do that, we will take a look at something that is called SIL, which is Swift Intermediate Language. And basically, when you write a piece of Swift code, and then you compile it, it goes through a series of stages. One of those stages is this intermediate representation that gives us a little deeper if you look at it, you can get a little deeper understanding of how actually your code works. If you want to experiment with it, there's a very cool, very old and very cool still working app by Alex Blewett, SIL Inspector. Basically, paste your Swift and you will get SIL. So what SIL does is, let's say we have this super simple structure, codable, so basically we parse this from JSON, single property, right? 3 lines of code. And SIL does this to it. So it generates all the conformances to equatable, to codable. Everything that codable gives us is visible in SIL. This is everything generated. This is how the code actually looks like and what is actually executed. Well, give or take, because there's more stages after SIL. Yeah, so first topic of the day, NS object. Not entirely NS object, more interop between Swift and Objective-C. This is something that's super cool because it allowed us to work with our existing code bases moving forward with Swift. But there are some nuances to it. And to quickly set the stage for this, a quick recap about how in both of these languages, what's the notion of a base type. So in Objective-C, obviously this is NS object. Everything you have in Objective-C inherits from this. For those of you who worked with NS proxy know that this is an exception. In Swift, there is no base type. So if you declare a class without inheritance, it will be just that, a standalone class. And obviously, structs don't inherit because they cannot inherit anything. And then if we have base types, there is also the notion of sometimes we need to have that kind of special property that we want to store anything in it, right? Be it a string or an integer sometimes. It's not good programming practice to do this, but sometimes it may be needed. So in Objective-C, this was achieved through this special ID type. And in Swift, we have 2 of those. Any object, which is tailored for classes or objects that do have reference semantics, and any that basically can store anything. Structs, enums, closures, classes, everything. So yeah, let's start with a core truth. Any is any, and we can safely assign anything to it. In this case, a plain old integer. So what happens if we want to assign, so we cannot assign an integer to any object because, as I said, any object is tailored for classes, right? So it will be super weird if we couldn't pass an integer, very base type, right, back to Objective-C for this interoperability. So what we can do is basically we can cast this to NS number, and now it's good to go. So we are telling the compiler, hey, so this is a very plain thing, but let's treat it as this NS number thing. So let's see what the compiler now thinks about our any object. Is this an NS number? Well, it is, and it's also an int. So while we kind of promoted this to Objective-C world, we still know that it's under the hood just an integer. And now for a bit of magic. Is this a float? Should it be a float? Well, it is, or it isn't. This is a minor inconsistency that personally I'm kind of fine with it, because all integers can be represented in floating number. Well, let's agree to that. So technically, this check is not saying, is this an integer, but rather, is the value represented here, the value stored here, can it be represented as an integer or as a float? And for a sanity check, let's assign an actual floating number to NS number and see if it is a float and it's not an integer. So yeah, our sanity is intact at this point, which is very good. So what happens when we actually take our integer and want to convert it to this NS number? Because this is basically bridging two worlds. We have a structure, we have a class. How does this work? So the compiler is pretty smart about this, because in this case, at seal level, it figures out that basically what we need to do is create an NS number instance from an integer literal, plain and simple. And we could cast our integer directly to NS object instead of NS number. And in that case, a little bit different method is used, because we are now no longer going through NS number initializer, but we are going through something special called bridge to Objective-C, which we will take a look at in a second. So armed with all that knowledge and quick little experiments, let's start asking the real questions. So what happens if we have our own objects, right? Because integer and this number, this is all built in. Apple handled this for us. So what happens? Can we assign a class, a random Swift class to any object? Can we assign a random Swift struct to any object? Well, the first one worked. The second one obviously kind of failed, because struct cannot be a class, right? But Xcode will give you a fix-it for it. It will suggest that maybe you want to cram this struct into an as any object. And if we apply this, it's not a fake fix-it from Xcode. It actually does work. So let's see if this checks out, if our class became an NS object and what happened to our struct. So our class is not an NS object, which is good, because it does not inherit from NS object. So it would be kind of weird, right? And what about the struct? So our pure innocent struct that had no notion of classes and reference semantics, not to say Objective-C, suddenly became an NS object. So why, and what's the reason for it? So if we look at this piece of code, basically casting our custom struct into any object at seal level, we see a very similar method to before, right? We have bridge anything to Objective-C. Why? What's the reason for this? And at that point, looking at seal was pretty useless, because there was only a reference to this method. So I did what any sane person would, and I downloaded the entire Swift code base and source code and started searching through it, and found this beautiful, beautiful and very informative comment. So that method, bridge anything to Objective-C, basically does that. it bridges an arbitrary value to an Objective-C object. And if T is a class type, it is bridged verbatim. So this is what happened in that first case. Our custom class cast to NS object didn't change its identity, right? It was able to be represented in Objective-C world. It would not be accessible there, but memory-wise, it had the same semantics. If our type were to conform to this special Objective-C bridgeable, this is a hidden protocol, unfortunately. I would have loved to play with it. Then it basically will call that method, and we can, well, you can play with it, but just not ship it. You can turn your custom Swift objects into a completely different Objective-C representations. So you can turn a Swift string into an array, NS array at Objective-C level. And otherwise, they use boxing, because a struct cannot be inherently represented in Objective-C. Objective-C, well, it had a notion of C structs, but they are a little bit different from Swift structs. So in this case, they will take our struct, they will wrap it in a box, and then it will be, again, not interfaceable from Objective-C, but it will be allowed to live in that world. And this is the entire code, well, almost the entire code. This is the interface of that box, which is super simple at interface level. Implementation level is a whole other beast. There is a lot of custom memory alignment happening. I'd be very happy if someone knows their C++ to discuss this code, because I don't understand it. But we really don't need to. This is the important part. So we know how all of that worked, right? How our pure innocent Swift struct suddenly became an NS object, but why do we need this? So because we had to, when both languages, when Swift became available, and we had to start coexisting and interfacing between those two languages, there had to be a notion of representing the anything type between those, bridging the anything type between those languages. And before Swift 3, ID was represented as any object. Because obviously in Objective-C, most things you had were classes, right? So it made sense that if something is of an ID type, there is a class under the hood, so it is an any object. After Swift 3, they changed this so that ID types are represented as any. And the reason for this is actually not Objective-C to Swift interop, but Swift to Objective-C interoperability, because this is what allows us to pass our Swift structs as arguments in Objective-C APIs that otherwise expected ID objects. Before Swift 3, if you created an NS error and passed in a user info dictionary there, which is obviously an NS dictionary under the hood, and expects ID types in its values, you couldn't pass a struct directly there. So kind of developer, the ease to write code was the driving factor for this change. That's why our pure innocent structs, when cast, can be cast to NS object and can live in Objective-C world. And now let's switch gears a little bit and talk a little bit about optionals. So we saw this code earlier. We know that anything is anything. Well, that we can store anything in any, right? And Swift also has a kind of a special value that's called nil, that's used to represent nothing, or more precisely, the absence of value. So should this work? Can we store nothing in anything? Well, I see some head twisting. Yeah, it kind of does not work. And the compiler will tell us that it cannot do this, and it suggests a fix-it, but it's a boring fix-it, because it basically tells us to turn our typing into an optional type, which would be fine. But this is not what we came here to do. We came here to break code. So what is an optional? An optional is basically an enum in Swift that has two cases. Some, which will store our value if it's there, and none, that is used to represent the nothingness, right? That there's no value actually in the optional. And typically written using nil. Well, if it's typically written using nil, does it mean that we can do a typical thing and write it this way? Yes, we can. And now we've stored basically nil in any. So we have a non-optional value property storing nil. And yay, hooray for us. But what are the consequences? Why does it work this way, not the other way? Because this is basically true. Optional none is equal to nil. This is true. It will always be true. So why does this work and this doesn't work? And this is basically quite simple. It's because this is, we are directly telling the compiler what value to use, or in this case, it's a case of an enum, right? We are super explicit about our intention. And this is sugar syntax, and sugar is bad for you. So pizza was better, I guess. And some of you may notice that the source of that sugar syntax was on the previous slides, and it's this protocol, expressible by nil literal. And optional type conforms to it. So if you define your property as an optional, you are allowed to use nil keyword for the shorthand syntax. And since any does not conform to it, well, that's not allowed directly, right? We cannot use the shorthand, the sugar syntax. So if expressible by nil literal is a protocol, there's no underscore, so it's available. We can use it. Does this mean that this is OK? I mean, it's OK from compiler's perspective. It will work. It will compile. You will be allowed to ship it in your app. But I guess the question is, should you? Because I fully expect this to happen if I ever wrote that snippet in a PR. I have not yet found an even weakly justifiable case to use this code in production. I will cherish the day that I do. And I hope that people who will have to refactor it won't have my email address. Yeah, last topic of the day. We will keep a little inside optionals, and we'll talk about optional chaining and property observers, not property wrappers, property observers. So what is optional chaining? A quick recap. This is also, again, a super nice and fun syntax, because if we have an optional value, we can use the question mark after the variable name to basically tell the compiler, hey, if this is not nil, please carry on. If it's nil, just skip the rest part on our right hand, right? And this is a quick sample from Swift docs, and basically showcases also that our optional chaining short circuits execution in assignment. So in this case, if residence were to be nil, our create address method would not be called because basically there's nothing to do, right? If we have nil in the middle somewhere, the rest of the code is moot. So it doesn't make sense to execute it. Let's test this. If you were on Mobile Warsaw Discord previously, you probably saw this code already. So what we have here is we have a class that stores a string. We have another class that has our property class as its property, which is an optional. We have a bit of code that tries to assign something to this optional property, right? This is basically replicated code from from the from Swift docs. So let's see, and there's a bit of did set sprinkled for good measure to make sure that since property is nil, that no side effects are executed, right? That we get the short circuit behavior we were promised. And in this case, this works. But again, this is boring. Let's break this. Let's change the code a bit. Who noticed the change? It's very small. We just changed the class to struct. And normally, if you have a huge code base, right, and you make the decision, way, let's make this class a struct. This can be cause for worry, or well, the other way around too, sometimes. Because we have different semantics, stuff may break because of this. But this is a very simple, very short, very doing nothing code. This should be an innocent change here, right? So, well, the compute message was not executed. There's no print there. But the did set was. So what happened? What was set if anything is nil and the method that should return us, give us the value was not called? What happened here? Yeah, this is a lot, but this is basically the important parts of seal for both cases, for the struct and the class. It does look a lot, but basically these parts are virtually the same. This is checking if our property is non-optional and some cleanup. Let's focus on the simpler case for now. So in case of class, what happens at seal level is that the first line we have here, it basically gets the getter, however it sounds, well, finds the signature for the address for the getter method of our property, executes it, stores the value to a variable. This is a setup for the seal equivalent of a switch statement, select enum address, basically saying that if there is something, store one value, if there is nothing, store the other value. And this is a conditional break, which checks the value we got from the previous statement. If it were true, we'd jump to BB2, if there was something null property. But since it's false, we jump to BB1 and do just some cleanup, right? We destroy the addresses we stored. We deallocate some memory. This is, again, boring. Struct case, a bit more interesting. Not that many changes. Basically, these three things have changed, which are the crux of the thing. So instead of accessing our property through a getter, we now have something weird called modify. And this is a special accessor that's, again, generated by seal for us under the hood whenever we try to mutate a struct. So it will do some setup for us. And then instead of apply, we have begin apply and end apply. So that's how the modify thing works. And this is the whole reason for the shenanigans that are happening. Because modify is a yielding thing. And if you ever saw yield in code and understood it immediately, I applaud you. Because this is getting weird. So yield all hope, ye who enter here. So what is happening basically is that as our code is executing, as we begin the apply, we start our modify method. We prepare our property for modification. Swift, the compiler, kinda didn't figure out at this point, forgot to figure out that it's gonna be nil. And then when we yield, we return the execution back to our main method, right? So then we got the property. The modify does not know it's nil. I don't know why it doesn't know it. And then once we figured out that it's nil, we call end apply because we don't need the access to it anymore. And end apply, what end apply does is it calls the resume block of yield. And what does the resume block of yield do in this case? Well, it very stupidly calls the did set out of the box without any conditions on it. So even though no code, no actual meaningful code was executed, Swift decided to call the did set observer for us. And it's not like there's no support for this at SIL level, because end apply was used here, and it basically tells us that it will return to the resume path. But if SIL was a bit smarter here, it would call abort apply, which would give return the execution to modify to the unwind block of yield, which just does cleanup. And then there would be no did set called. Thankfully, this has been reported as a bug. Regretfully, it's still open. Even more regretfully, it's open since 2018. And that's pre-COVID times, for those of you who count time like this. So, and even worse so, there hasn't been any chatter in these threads since 2018. Nothing new. So, well, it is a bug. Maybe they will fix it. Maybe they won't. I'm not super hopeful at this point. So yeah, that's something to kind of look out for. Yeah, Arthur Clarke once said that supposedly, any sufficiently advanced technology is indistinguishable from magic. And I guess that's not a huge leap to paraphrase this to that any sufficiently complicated code is also indistinguishable from magic. So write your code responsibly. Beware for magic in Swift. Be smart, but don't let the compiler be smarter. And yeah, I hope you had a little bit of fun.